radical and rational expressions. One of the rules about this first example is we have a fraction, and in a fraction we cannot have in the denominator, you can't have 0, you can't have imaginary numbers, you can't have a rational number, you can't have fractions and negative numbers. One good thing about all the things I listed, we can work with every one of them except for the 0. Of course, the 0 makes it undefined. So, we see that we have this rational number down here in the denominator, this root, and we can't have the root. So, what I'm going to have to do is decide what I need to multiply the bottom by to undo that root. But I have to be careful because I could accidentally put the root back in. So it's very, very important. What I notice is that I have this 1 here. So I'm going to write the 1. I know 1 times 1 is just 1. It's not in a root. We're good. Of course, the square root of 1 is 1. I see I have a positive. So in order for me to make this work, I have to do the opposite. If this is positive, then that means I need to do negative. I need to make it a negative. And it is a square root. So that means if I multiplied by another square root with the same radicand, which is the number inside it, then I'm going to undo everything and it's going to get rid of the root. So I'm going to put square root of 5. But there's a rule. Whatever I do to one part, I always have to do to the other part. So if I did this to the denominator, that means the numerator must be multiplied by the same thing. So I'm going to put 1 minus square root of 5. So let's get started. So we're going to use the rule of distribution. I'm going to say 4 times 1 is 4. And then I'm going to say this positive 4 times this negative square root of 5 is a negative 4 square root of 5. All over. So the bottom, since there's 2 terms here in this denominator and 2 terms in this denominator, that means that we're going to use the full method. So I'm going to have 1 times 1 is 1. 1 times a negative square root of 5 gives me the negative square root of 5. I'm going to have a square root of 5 times 1, and it's both positive. And then the positive square root of 5 times a negative square root. Well, negative times positive is negative. But there's 2 of them there. So that means I'm going to have 2 5s inside the root because, just a little side note, if this will help you, a side note, so you can see that if I said square root of 5 times the square root of 5, that's the same as saying both of those 5s under the same root because they're both the same root. They have the same index, they're both squares, so we can do that. Well, if I look at it close enough, what happens? My middle term here, and I apologize, it keeps going blurry back and forth. I changed the setting. I'm not sure why it keeps doing that. But when I see that this negative square root of 5 plus this positive square root of 5, they cancel out and go to 0. That's why it's so important that our signs are the opposite. You see that? If that was a positive, then I would have had a root still left behind, and it would defeat the purpose of going through all this trouble. So I got rid of this middle term. So let's clean this up. My top number, I got 4 minus 4 square root of 5 all over 1 minus, well, over here on this side, let's talk a little bit more about this. Square root of 5 times 5 is the same as square root of 25. And what is the square root of 25? It's just 5. So that's what's going to go here. So now, I got 4 minus square, don't forget the 4 there. 4 minus 4 square root of 5 divided by 1 minus 5 is a negative 4. I said we can't have a negative sign in the denominator, and that's true, we can't have one. So what we can do is pull that negative sign to the top. But something else I noticed, and I'm going to have to rewrite these problems somewhere else. I didn't allow myself enough room. So let's come down like this. I can rework those on another page. Let's come down and let's rewrite this. Let's take this negative sign. You got two options. You can put it in front of the fraction or you can put it in the numerator. Let's just put it in front for now. So I have 4 minus 4 square root of 5 divided by 4. And what I notice is that I have a 4 here, a 4 here, and a 4 here. The only way I can reduce is if and only if it reduces with both these terms on top. And what happens? 4 goes into 4 once, goes into it once, goes into it once. Right? So now I have this negative sign in front of the fraction. 1 minus square root of 5 over 1. But that's not how we write our answer. In simplest form is not over 1. And we need to distribute that negative sign to everything up here. And when I do that, it changes it all. So now my answer becomes a negative 1 plus square root of 5. And that is my answer. This next problem here I'm going to rewrite on another page. So example 2 says to have m raised to 5 halves, square root of 289. The rule says that whenever we have this root and we write it like that, we got the nth root of a to the p power. It can also be written as a raised to the p power divided by the nth root. That's what that means. That's just the power of 5 at a square root, meaning that if I wanted to rewrite this m, it could be rewritten like this, right? That's all it's saying. Well, if I want to clean this up, I can come back and put that 5 on the m. So I have the square root of m to the 5th. And the rule says if I multiply by like bases, I add the powers. So what if I rewrote this as m to the 4th times m to the 1st? Would you agree that 4 plus 1 is 5? And now I can actually take the square root of that 4 out and it gives me m squared. Of course, this m to the 1st, it didn't leave. It stayed right there inside it. So now we have this much done. Let's work on the square root of 289. Well, some of you will probably get frustrated and tired and just use a calculator and just type in the answer of square root of 289 and you'll find out that it's 17 times 17, which also can be written as 17 squared. Well, the root and the power are equal, so my answer is going to be 17. Now, this is not how I'm going to write my answer. I'm going to clean this up. Since I want to be careful and I don't want it to go in the root, I'm going to bring the 17 to the front, and then I'm going to put the m squared square root of m, and there's my answer. And I'm going to do the other parts on the next part, on part 2.